This week, we're going to continue our study of financial mathematics and look at compound interest. So last week, we just took a basic introduction to simple interest. And remember that. So simple interest is just calculated once in the time period, right? So if you have annual simple interest, then that means, say you're talking about a savings account, right? You have your money in the savings account once at the end of the year. You're paid the interest, very simple. Compounding interest actually calculates interest more often than that. And you start either earning interest on your interest, right? So it becomes part of the principal and you're earning more interest, or you are owing less, right? Because the payment comes off, and so then the interest is calculated on what's left, unless you're not making payments, and then you're owing interest on your interest, right? So compounding is a word that just means the number of times the interest is calculated in a period. So if you're talking about annually, then it's how many times does the account earn, is the interest added, is the interest calculated. So the formula has the exact same components as simple interest with one addition. You'll see a new letter N, and N represents the number of compoundings. So if you have an account that's compounded monthly, N would be 12. If it's compounded semi-annually, it would be 2, right? So it's just the number of times that interest is compounded or added. We will also, so you'll see a similar formula, but it's a little more complicated because we have to introduce that extra compounding. But the components are the same. The variables represent the same ideas. So hopefully you will just be able to take that formula and manipulate it to find what you need to find. We're going to introduce this lesson the idea of present value instead of just future value. So future value, if you remember last week, is how much money you will have at the end of a set period of time in the future, right? Based on money that you either put into an account to earn interest, or it's the future value of a loan, like what the payoff will be at the end of the loan period. So we're going to kind of flip that and talk about what the present value would be. So for example, if you're going to retire in 20 years and you want to have X amount of money when you do, what is the present value that is needed given the current conditions that will accomplish that? So we can work backwards, right? I want $100,000 in 5 years. Well, how much do I have to invest in today's market with today's interest rate to accomplish that? So that's present value. It should be pretty self-explanatory, the difference between future value and present value. So with this new compounding formula, another application that you will see and that is useful is inflation. Inflation follows the interest formula that will be introduced. And so you can take any price or salary currently, you can imply what the expected inflation is or what the current inflation is and figure out what that will cost in the future. If you're talking about salary, you can take, okay, this year, this is my salary. Inflation is expected to be this much. What will my salary need to be 1 year from now so that I can live the same, right? It doesn't mean that so that it will, I will be able to have the same lifestyle with the same things. What will my salary need to be under that inflation? So for example, I think the book calculates a $35,000 salary. So say today you have a salary of $35,000. Inflation is expected to be 6% over the next year. That's a really high inflation, which hopefully we won't see. But in a year, if inflation is 6%, then that means if you put it in the formula, calculate it, you will see that you will need to have a salary of $112,000 in the next year to just live the same that $35,000 allows you to live today. So that kind of gives you a snapshot into how inflation works, right? It's not that everything is just costing more, it's that the value of the dollar that you have is worth less, right? It's the buying power of the dollar. So you will practice with inflation, seeing what happens there. So with this idea of compounding, what you start to see is that a stated annual interest rate might not give you the best picture of what your money is doing over time. So you will see two different types of interest rates stated often, and you're going to look at how to calculate those. So the annual interest rate is just the nominal rate, the annual rate that is being applied. But if it is being compounded more than once a year, the effective rate, how it actually is working for you or against you if it's a loan, is actually a higher number. So for example, if you have a 7% nominal rate, that's the stated rate, but your interest is being compounded daily. If you put that in the effective rate formula, what you find out is that the actual interest rate, the effective interest rate, is 7.25%. So it's higher. The more compoundings you see, the higher you would expect the interest rate, the effective interest rate to be. So you're going to look at how to calculate between those two. And then once that's 11.2, and then you're going to move into 11.3. And in 11.3, you're going to look at how to apply these ideas to credit cards, to car loans, and to student loans. So for credit cards, they have a more complicated interest calculation because if you borrow money for a car or house or something like that, that's kind of a fixed amount, right? It's upfront, you get this much money and then you pay it back. But with credit cards, the amount of money that has been borrowed can vary as often as daily, right? I mean, every time you use the card, the balance of what is owed changes. So they're left with the task of figuring out what number, what balance, what amount are we going to calculate interest on. So one of the most common methods, and this is what you're going to practice in this section, is to use what's called the average daily balance. So across the period that they are calculating interest for, they will add up the balance every day. So say it's a 30-day billing cycle. They'll add up the balance for all 30 days, right? Just sum that up. And then they'll divide by 30 to get the average daily balance. And then that's the number that they will apply interest to. So you're going to practice calculating that the way a credit card company would. And that would take into account, right, payments that are made or things that are charged. And then you will also look at how to compare those annual rates and those effective rates for credit cards. And that can sometimes be significantly different. If you have a lot of purchases you pay interest on, the stated rate might be 10%, but that effective rate can go as high as 17 or 18%. So it's sometimes almost double or more. So just it's a good thing to be aware of when you're dealing with credit cards. And then finally, like I said, you're going to look at car loans, house loans, things like that. They kind of work the same way. And you're going to learn how to calculate a payment, which is probably the thing that people most often want to know, right? Because if your interest is compounded, it's not as simple as here's the total amount, here's the total payments, I'm going to divide and that's what I owe, right? You have to factor in how often the loan is going to compound the interest that is owed. So there's a formula that allows you to do that, but you can say, right, if I know I have this interest rate and I know this is what I'm borrowing, if I do it for this many years, what will my payment be? If I do it for this many years, what will my payment be? And you can see how to go back and forth and how that impacts that for you. So you're going to practice calculating that. And then that'll take us through 11.3, which is what we're doing this week. We are going to continue another week into financial topics. So that's probably one of the biggest topics that we'll cover because it is so prevalent in just our day-to-day life. So I will see you in the next video.